Welcome back, ladies and gentlemen. Dr. Robinson here again. This time we're going to review for the grade 7 New York State mathematics exam. We'll be getting our examples from the 2023 exam. So here we go with show number 1. If you need help with your homework, there's Dial the Teacher Homework Helpline at 212-777-3380. They're open from Monday to Thursday at 4 p.m. to 7 p.m. Give them a call. They'll help you out. They're very nice people. Watch our show Math Time on Tuesdays from 4:30 p.m. to 5 p.m. only on Optimum Cablevision, Channel 15 in Peekskill. Don't forget, we have YouTube study videos. My channel name is Dan Robinson, PKMS, Peekskill Middle School. Subscribe to our channel. Give us a thumbs up if you like what we're doing. And better yet, write me a comment, because I do write back. Check out our latest release, PKMS Math Prep 22. All right, let's get started. Joelle has 3 buckets which contains different amounts of liquid. The amount of liquid in each bucket is listed below. 7.5 liters is in the first bucket. 5 3/4 in the second bucket, and 6 3/4 in the third bucket. So Joel is going to mix all of these liquids together. Then he pours all the liquids equally, that's an important word, into 5 containers. So he's mixing all of this up all together, so that all together would help us out. So they want to know how many liters of liquid does Joel pour into each container. So he has 5 containers that he's going to pour all of this liquid up here into. So we need to take all of those liters and put them all together, or another way of saying put them all together is add them up. So I'm going to get my calculator and add up all of these different fractions. So I have a different calculator than you do. So I recommend it. TI-34 is a good one, so you can get it. Amazon, usually a good place to look. So 7.5 is in the first bucket. Let me move over. Plus the second bucket, 5 3/4. And now let me add that to the third bucket, 6 3/4. Okay, move that over. So there's all the liquids. Let me add them up with my calculator. And it comes out to a nice whole number of 20. L for liters. So he has a total of 20 liters. So what is he going to do? He's going to divide the 20 liters up into 5 containers. So divide them up. So you can fill up those 5 containers. Well, 20 divided by 5 will give them 4 liters per container. So that's what I go with that answer. So how many liters can he pour into each container? He can pour 4 liters into each container. All right, let's move on. A student has a bus pass with the balance of $30. Okay. Each time the student rides the bus, the balance on the bus pass decreases by $2.25. Okay, so he's paying his bus fare, they want to know what's the greatest number of bus rides the student can take using the bus pass. So there are a couple ways you can look at it by taking the $30 that he has and make a list. $30. So here's the money, and here's the offer rides. And remember, you're subtracting for each ride $2.25. Wait a minute, let me. For each ride, subtract $2.25. And that'll give you the amount. Now, we can keep doing that, but it might take a while. So I would try to figure out based on, and there's another third way we can do it, by estimating. If I say 10, if he takes 10 rides, let's clear all this out. He takes the $2.25 and multiply it by 10, and that'll give you $22.50. So he can take 10 rides, but he has some more left over. So I'm going to eliminate A because he can take more. Because remember, he has $30, and if he spent $22.50, hey, he has about $8 left. So take some more rides. So let's keep going. So this is another way I would take the $13, and multiply that out and see what that is. So we can be, and again, we could be at this for a while. So I'm not going to do it that way. So I'm going to show you more of an algebraic way. So let's clear this out. Okay. So he has a balance of $30. And that will give us $2.25 per ride. And I'll call the rides X. And I made an equation. $30 equals $2.25 times the number of rides. So instead of doing those guess and check methods, I'm just going to divide $2.25 by both sides. Let me erase that because I don't like that. Messy. Never be messy with your math. Okay. That's much better. So I'm going to divide, get my calculator again. $30 by $2.25. So let's clear this up from the first first question, and divide by $2.25. And this will give us 13.33. So 13.333, and I'll put a line over that. So, and let me bring that out. So that way you can see what we did. So you can ride 13.3333 rides. So here's where you need to know the word truncate. Truncate means cut off, not round off, because people would try to round off and you would get lucky in this case. But truncate means to cut off. I'm going to cut this off because I really don't see myself riding 0.333 of a ride, because either you will take a whole ride or no ride, because you cannot take a third of a ride. So I'm going to cut that off. So 13 would be our correct answer of the number of rides the student can take on the bus. Okay, so choice B is our best answer. And you can even go ahead and multiply like we did 13 times, and might as well clear, uh, 13 rides times $2.25. That comes up to $29. And let me pull that out. That comes out to $29.25. So you could see it for yourself. You would have 75, he would have 75 cents left over. That's why B is the best answer. And that's the algebraic way. So you saw a lot of methods in doing it. Choose the one that's best for you. I hope you understand what's going on. If you're not sure, rewatch the movie and hopefully you'll get a better understanding. All right, Joseph has a part-time job. The graph below represents the amount Joseph earns in dollars for the number of hours he worked. So this is Joseph's earning. So based on the graph, which equation, oh, we got an equation we're writing here, can be used to determine the earnings, and that's over here, it says earnings, and that's on the y-axis, by the way, in dollars, so it's dollars, so we're talking about money over here, for every hour. Hours is over here. And remember, when we write an equation, we better have an equal sign that he works. So X. And if you remember when we were talking about the constant of proportionality, we are interested in each 1 hour that he works. So how did we get the equation? Because we got some interesting choices over here. You take a line that goes through the origin. Here's the origin. And it's a straight line. And we look for a point like this one right here. It intersects the y-axis over here. And that would be, if we count, 20, 40, and between that would be 30. And go down to the bottom to the x-axis, if you remember how we read these proportional relationship in graphing, and 2 hours. So we have our constants of proportionality. I shouldn't say that. We have our equation for the constants of proportionality. We're looking for the k, and let me erase that. So where's my eraser? So we have our formula for finding the constants of proportionality, because that's part of the equation we wrote right over there. So we're looking for the constant, and that formula is y over x. So our y value is what we need, the 30 on the top, and that's dollars, over that number of hours down here, which was 2. And now we have a fraction that we can find the k value, or the constant. 30 divided by 2 is 15, and that's dollars per hour. $15 per hour. So we put that right here, and I'll write it out. Y is equal to $15 per hour, X. So there is your equation. So hopefully you remember important things like how to find the constant of proportionality, k equals y over x values. And remember your x lines and your y lines. So which one is which? And that'll help you decide which is which. Now, A looks good, but it's not the right one because there's a decimal point there. B is the one we need. He makes $15 per hour. Now, if you want to check that out, Why don't you go to another point like this one? And 100 is on this line and 80 is that one. So between that is 90. Notice they skip numbers on purpose. So doing a little skip counting there. So our K value for this point would be 90 over 6. And guess what that equals to if you divide that? I know you know, but I'm going to get my calculator just to be sure. 90 divided by 6. And that'll give us a constant of proportionality just to check to make sure we were sure about our answer. So his equation is every time he works an hour, he gets $15 for each hour. So that was choice B. All right, Dr. Rob, keep going. A bicyclist travels 6.5 miles in 2/3 hour. What's the average speed in miles and per hour of the bicyclist? Now, what I like about this question is it starts from what? Average speed. And that's some type of rate that this person is going in miles per hour. Well, right here, miles, how many miles did he go? 6.5. Because we were talking about constant of proportionality a second ago. So the average speed in miles per 1 hour would be the K value or constant of proportionality. So, so they give it to you miles per hour. How many hours did he go? Right. 2/3. Yuck. Look at that fraction. Well, I remember, if you remember, Dr. Rob did a video on complex fractions and how to deal with them because they're not really that scary because of that fraction on or mixed number on top of a fraction. The bar means to divide. And what are you dividing? Just the top numerator divided by the denominator. And that's it. Yes, that's it. So look at these answers. They look scary, but don't you get scared. Why, Dr. Rob? Because you have a calculator. So get your calculator, type 6.5. So make sure you know how to use your ABC button. And remember, your division symbol, so that way you don't have to use your ABC button again. So 2/3, 2/3, and move over and press enter. There it is, 9 3/4. Now if you got 9 and 0.75, that's no problem. Just use the other button to change that to, oops, I didn't change that. So sorry, folks, didn't change that. So I'll have to remember to change that next time. Let me get my calculator back and bring that out so you can see it. Uh, this is not working.